Hi, this is an ordinary three-part stoichiometry problem where we're given the mass of one reactant, told that it reacts completely, and asked to predict the mass of a product. So this is question 14 from your workbook, and it's 14D. So here I've written out the equation for you. Let me transition over to what I've been writing. I've written the equation for you. 2 mercury 2 oxide produce mercury and oxygen. So this is a decomposition reaction. We start with 3.87 milligrams. So I labeled it under the mercury 2 oxide. I've calculated the molar mass before I started recording the video using the periodic table. So I just looked up molar masses for mercury and oxygen and added them together. And I also calculated the molar mass for the O2. So I know I'm going to calculate the number of moles of my reactant. I'm going to use that to figure out the number of moles of product, and then I'm going to convert to a mass in the third step. So 3 steps. So step 1, number of moles of HgO is equal to mass over molar mass. 3.87 milligrams divided by 216.58, and I'm keeping 2 extra digits that weren't sig figs when I did that molar mass. So 3.87 divided by 216.5894. So on the calculator I have 0.0179 to 3 significant figures. 0.0179. Now, if I cancel grams with grams, I have 1 over moles in the denominator. Moles is going to move to the numerator, and I'm leaving the prefix milli. Now, you could have done a unit conversion, but you'll see that there's no need to do that. If you do the unit conversion and express your answer in scientific notation, it's perfectly acceptable, but engineers and engineering technologists don't normally do that. So this is the way technologists and engineers normally do it. Step 2, to figure out the number of moles of oxygen, it's equal to the number of moles of the reactant HgO times the mole ratio, and the mole ratio is always the coefficient of the required substance over the given substance. So 1 over 2 in this case. So divided by 2, and we get 0.00893 millimoles. Remember, we're keeping the unrounded value in the calculator into each next step. In step 3, I need to work out a mass of O2 from its number of moles and molar mass. 0.0893 millimoles times the molar mass, 31.9988 grams per mole. So that's still on my screen, times 31.9988. 0.286 to three significant figures, 0.286. And we can see moles cancel, and the answer will be milligrams. 0.286 milligrams.